lines and do plotting much more easily on a Mercator chart than if we had a distorted scale. One of the things you want to look at when you initially use a chart is to see what the depth scale is on that chart. For example, if I look at a particular depth mark on the chart, I'm reading here a 90. And the question is, well, what does that 90 mean? Well, it means the depth of the water, but is it in 90 feet or 90 meters or what? I look at the border of the chart and it will have in big, large letters what that depth scale is. In this case, it's soundings in feet. It may also say soundings in meter or soundings in yards. The other thing that you notice on the chart are the distance scales. And these numbers down the left-hand border are actually the measurements between the lines of latitude. And in between each of these is a series of little tick marks, and each of those tick marks is 1 minute of latitude or 1 nautical mile. So that is your distance scale. 1 minute of latitude equals 1 nautical mile. There's a similar scale at the bottom of the chart, and this is indicating longitude degrees, but it cannot be used for measurement of distance. We never use the longitude scale for measurement of distance, only the latitude scale. The other thing that I look at on a chart is the compass rose. And I come over to this part of the chart, and here's a compass rose drawn in, and there's actually 2 sets of protractors drawn on the chart. One is the protractor that correlates to the latitude-longitude scale, and the other is a protractor that correlates to the magnetic scale. The magnetic scale on this protractor is actually turned to the left or counterclockwise. And that difference is called variation, magnetic variation. The protractor that correlates to the latitude-longitude lines are called true directions, and the one that correlates to the magnetic north are called magnetic directions. So the difference between true directions and magnetic directions is a difference called variation, and that variation changes with location on Earth. And in order to do our navigating, we frequently have to convert between true and magnetic directions. We use a formula, TVMDC, and this T stands for true. This stands for variation, which is the difference between true and magnetic. This is magnetic. This is deviation. Now, deviation is errors in the compass. And we set up a table based on our calibration procedure for the compass. But for a particular boat heading, we can come up with a deviation number as well. And then this last column is compass, what the compass on the boat would actually read. So for example, if I have a bearing to an object, you recall earlier I drew a line and I had 120 degrees. And that's 120 degrees true. And I put it in the true column. If I look at my chart and I look at the difference between the true and magnetic compass roses on this chart, I can read in the middle of this compass rose, it says variation 16 degrees westerly. So in this column, I can write 16 degrees west. Now, I have true and I have variation. If I want to know magnetic direction, adding those two numbers together, I'll get a magnetic bearing of 136. There's a question of whether we add or subtract that number. And there's a set of rules that we use for that. If we're moving from left to right in this table, left to right in the table, westerly variation would be added. And going from right to left, westerly variation would be subtracted. If my compass rose was the other direction and I had easterly variation, then as I move from left to right with easterly variation, I'm going to subtract. And if I move from right to left with easterly, I'm going to add. So those are the basic rules that we use and how to do that arithmetic. So I've gotten with that from true through the variation. I now have magnetic for that 120 plus 16 is 136. The next issue is the compass error. It's called deviation. You calibrate your compass and you come up with a table. And if I go to this deviation table, which is the compass error calibration table, and supposing I had 2 easterly deviation. Now, according to these rules, if I'm moving from left to right in this table, easterly variation I'm going to subtract. So I would subtract the 2, and I would end up with a compass direction of 134, because this is a subtraction. And that's the technique for TVMDC. There are exercises in the book that go through that in great detail. In chapter 6 of the book, we talk about lines of position. Lines of position is a concept where there's a line that we can draw on the chart, and what we know is that we're somewhere along that line. We are located on that line. And there are several different ways of establishing lines of position, and I'm going to review with you 3 of them. First of them is a bearing to an object. So, for example, if I take wood end light here on this chart, and I'm out here in the water at some location, I take my compass, my hand-bearing compass, and I sight on wood end light in the real world, and I find that that light is in a direction of 330 degrees magnetic using the compass. I take that 330 degrees and I come to my chart and I place my parallel rules on the magnetic compass rose at 330 degrees, and I now walk the parallel rules up until I get to wood end light. And I draw a line through wood end light. And I've drawn it on the chart, and it tells me that I'm somewhere along that line. What I don't know at this point is how close to shore I am or how far away from shore I am, but I do know that I'm on that line. The second concept for a line of position is the alignment of 2 objects. So if I look at my chart here, I can see that at the end of Long Point, there's a light structure 36 foot high. And if I look further, I notice ashore near Mount Ararat, there's a standpipe which is visible from the water. If I take my rule and I simply line up those 2 objects and I draw a line, then I know that I am somewhere along that line. I didn't have to use the compass rose for that purpose because I just visually lined up the 2 objects, came to the chart, lined them up and drew a line through, and I say I'm somewhere along that line. The third type of line of position would be a depth contour. Right here I see an 18 along this line, which indicates that this line, the boundary between the white and the blue, is an 18-foot depth contour. So if I'm on that line, my depth sounder would read 18 feet. And as I come in further to shore, I see another one which is 12. And as I come away from shore, I see another depth contour which is 30. And I go into this line that I just drew by lining up two objects. I can see that there's a depth contour which is an 18-foot depth contour. And I therefore know that I'm somewhere along that depth contour. The contour is drawn on the chart. The next plotting technique that we're going to talk about is dead reckoning, which is discussed in detail in Chapter 5 in the book. Dead reckoning is a technique where we use two pieces of information to plot an approximate position. It's not a highly accurate position, but it does give us a basis for the future navigational plots that we'll do. Dead reckoning is based on two things: the course that we have steered the boat, and secondly, the distance that the boat has traveled in a particular period of time. So the course that we've steered, we get off the steering compass of the boat. And let's say that we know what our starting position is. If I look at this chart, and right off of Long Point, I see a buoy, which is green 3 bell buoy. And let's say that I'm at that buoy, and I'm going to steer the boat on a course based on the compass of 115 degrees. So to do that, I come to my compass rose and I find 115 degrees on the compass rose, put my parallel rule on the middle and on 115, and now I want to walk the parallel rule up until I get to the buoy that I started from. Lay it down through the bell buoy and draw a line from there. Now that line is at 115 degree magnetic based on this compass rose. After having plotted the direction of the boat, I next get the distance. And the distance is based on the speed of the boat and how long we've been traveling at that speed. So let's say that we're traveling at 5 knots. If we've traveled for 6 minutes, and in that 6-minute period, the question is how far will we travel? A half of a mile distance that we've traveled. So I come into my latitude scale, which is the distance scale, and remember that 1 minute of latitude equals 1 nautical mile. And I come into here and I set my dividers, therefore, to half a mile. And I come over to the line that I've drawn from the bell buoy, and I put a mark out here at a half a mile using that divider. On that mark, I draw a half circle. And the significance of a half circle is that it designates a dead reckoning point. When I departed the buoy, I departed at 0900. So this represents a dead reckoning plot, the course steered and the distance traveled in that period of time. What it does not consider is the effects that current would have. If there's a strong current flowing in here, I don't know what effect that would have on the DR. And if there is wind blowing, it's going to be blowing the boat from one side or the other. I don't know that effect either. That's not included. The next plotting technique that we'll talk about is position fixes using bearings. You'll recall that we earlier spoke about lines of position, where we drew a line from an object that we took a bearing on, and we knew that we were somewhere on that line of position. Now what we're going to do is take two lines of position, and the point is that where they intersect will be our position fix. So an example of that would be, If I take a bearing on wood end light at 330 degrees, and I come to my compass rose, and I go to the magnetic compass rose, and I set my parallel rules on 330 degrees. I then walk the parallel rules up to wood end light, and I draw this line. That's now a line of position, and I know I'm somewhere along that line. I then take another bearing on another object, and I've chosen the light at the end of Long Point. And I take a bearing on that light, and I find that it's 30 degrees magnetic. So I go to my compass rose again, and I go to 30 degrees, and I walk that up to that light structure on Long Point, and I draw a line through that point. Where those two lines intersect is my position fixed based on two bearings. That can be marked with a circle and the time that we took those two bearings. If I take a third bearing and find out that that third bearing on another object intersects fairly close to the intersection that I just determined, then I'll have greater confidence in the position that I've determined. So I notice that there's another light buoy, G1, south of wood end light, and I take a bearing of 260 degrees. I come again to my compass rose, I set up my parallel rules on 260 degrees, I walk that up until I get to that buoy G1, and I draw another line. I now have three lines. Now you notice that that